Welcome to Fabrica Dentro. Today, we are entering one of the most unusual agricultural-to-fashion journeys we have ever followed. Far away from any traditional leather workshop, and long before a handbag begins to take shape, the story starts across an enormous open landscape covered by millions of giant elephant ear plants. The land seems to continue without end beneath a bright blue sky filled with large white clouds. Strong sunlight falls almost directly from above, reflecting from wet leaves and creating sharp flashes across the plantation. From high in the air, the individual plants gradually merge into one immense green surface, but as the camera moves closer, their extraordinary scale becomes clear. These are not small ornamental plants. Their stems rise like young trees, while their enormous leaves spread outward in wide green canopies, creating a strange agricultural world where workers and machinery appear tiny beneath them. The plantation is built across broad, flat land rather than a mountain valley. There is nothing to block the view toward the horizon. In every direction, the same giant plants continue across the landscape, their enormous leaves moving together whenever the wind crosses the field. Some surfaces still carry water from recent rain. Large drops collect along the deep veins before sliding toward the edges and falling onto the dark soil below. In wetter sections, the ground has turned into thick mud, and the tracks of agricultural machines are visible between the rows. This muddy environment may appear chaotic from ground level, but every section of the plantation is monitored carefully before harvesting begins. Moving rapidly through the field is a rugged agricultural monitoring robot. Its wheels press deep patterns into the wet ground while a bright green scanning beam moves continuously across the plants ahead. The system analyzes the lower stems, checks the size and condition of the leaves, and gathers information from one plant after another as it advances. The robot does not simply move in a straight line. It adjusts its route around thicker stems, slows beside unusual plants, and continues through sections where the crop is still developing. Above the machine, enormous leaves overlap like a roof, sometimes briefly blocking the sunlight before the robot moves into another bright opening, the information collected by this machine allows the field team to identify individual plants that have reached the required maturity. Among millions of nearly identical green forms, one exceptional plant is selected for a closer inspection. Its stem is considerably thicker than those surrounding it, and its largest leaves spread outward so widely that they cast broad shadows across the muddy floor. From the bottom, the stem looks like a massive green column. Following it upward reveals the full structure of the plant, layer after layer, until the view reaches the enormous leaves at the top. Against the white clouds, their size becomes even more dramatic. This is where human inspection begins. 6 workers wearing matching protective uniforms appear between the plants and run toward the selected specimen. The soft ground makes every step difficult. Their boots sink into the mud, water splashes from shallow puddles, and the enormous leaves around them move strongly in the wind. When they reach the plant, they immediately spread into different positions around the base instead of standing together. Each worker has a purpose. One watches the upper canopy, another checks the surrounding ground, and the senior member of the team prepares to open a small section of the stem. Using a heavy field blade, he makes a controlled strike against the thick outer tissue. The impact opens a narrow section and exposes wet internal fibers beneath the surface. Moisture begins to collect immediately around the cut. Rather than continuing to cut blindly, the worker inserts a dedicated inspection probe through the opening. This allows the team to evaluate the internal condition of the plant before committing to a full harvest. The reading is checked, the exposed fibers are examined, and the surrounding workers confirm that the plant has the required strength, moisture level, and maturity. Once the selected plant is approved, the area around it is prepared. Workers move loose vegetation away from the base and create a clear path in the direction where the plant will eventually fall. Because of the extraordinary size of the leaves, a badly controlled fall could damage nearby plants or equipment. The team therefore studies the natural lean of the stem, the direction of the wind, and the open space available around it. Only after the area is ready does the heavy harvesting equipment enter. The harvesting machine is designed specifically for oversized plant material. Its large wheels push through the mud while the body of the machine remains high enough to move safely around the thick stems. One operator controls it from inside the cab, while another worker remains outside and guides the approach with clear hand signals. As the machine closes the distance, its hydraulic cutting assembly begins making small adjustments. The blade does not simply swing into the plant. It is positioned carefully at the same area that was tested earlier. The machine stops. Hydraulic pressure builds. The massive blade moves forward and touches the wet stem. At first, almost nothing happens. The plant compresses slightly around the cutting edge. Then the blade begins to enter. Fresh moisture appears along the cut, and long internal fibers start stretching across the opening. With every additional movement, the blade moves deeper. The wet structure separates slowly, producing one of the most satisfying moments of the harvest. Fibers pull, tear, and release while the upper canopy begins responding to the weakening base. The final portion of the stem holds for a moment longer. Above, the giant leaves begin shaking. Water trapped inside their broad surfaces slides rapidly toward the edges. Workers step farther away. Then the remaining fibers separate, and the entire plant begins to lean. At first, the movement is surprisingly slow. The enormous canopy shifts sideways and the leaves fold against one another as gravity takes control. Within seconds, the fall accelerates. The huge plant drops toward the wet field, and when it finally hits the ground, the impact sends mud and water outward. Rainwater that had been resting across the leaves bursts from the surface. Several neighboring plants move from the air displaced by the fall. What stood moments earlier like a small tree is now spread across a large section of the field. Harvesting the plant is only the first challenge. Moving it is another. Workers approach the fallen material and begin separating the broad leaves from the thick central sections. The leaves bend under their own weight. Their edges drag through the mud, and water continues dripping from the veins. One worker cannot simply lift an entire leaf and walk away with it. In many cases, 2 or 3 people are required to control a single piece. One worker pulls from the front, another supports the opposite side, and a third prevents the middle from folding beneath itself. Some leaves are dragged across the ground, leaving wide trails through the mud. Others are moved using long guide poles so workers do not have to stand directly beneath the heavier sections. The physical difficulty of the operation provides a clear sense of scale. These leaves may be flexible, but their enormous surface area makes them awkward to handle. At one point, one giant harvested leaf lies almost perfectly flat. A worker carefully sits near its center. The leaf flexes under his weight but remains broad enough that there is still a large green surface visible around him. This brief moment demonstrates the true size of the material better than any measurement could. Nearby, other workers continue dragging harvested leaves toward the staging area, making it clear that this is still an active industrial operation rather than a staged display. In another section of the field, a worker prepares a chainsaw for the thickest remaining connections. The tool is not used for every cut, but some sections are simply too large for lighter equipment. The chain enters the wet plant material and immediately throws out tiny fragments of green fiber. Moisture gathers along the cutting path. The sound and motion are aggressive, but the cut remains controlled. Once the section separates, another enormous leaf drops onto the growing collection beside it. Harvesting continues throughout the approved area. New plants are selected, tested, cut, and moved. The quantity of material increases rapidly. At first, only a few leaves lie across the collection ground. Then entire rows begin forming. Soon, the rows become broad heaps, and the heaps begin merging together. Eventually, the field contains a mountain of harvested elephant ear leaves. From ground level, the accumulation rises like a giant wall. Individual leaves can still be recognized along the base, but higher sections overlap in every direction. Wet surfaces reflect the sunlight, while muddy water drains slowly downward through the mass. Some leaves slide from the upper portion and settle lower as the pile rearranges itself under its own weight. Workers at the base appear extremely small compared with the giant green structure above them. Manual handling has reached its limit. Heavy machinery now takes over. A large grapple machine approaches the pile and raises its claw high above the harvested leaves. The jaws open before descending around a huge section of the material. As the claw closes, the flexible leaves fold and compress naturally. Water and mud squeeze from between the layers. Loose edges slip from the outside while the main bundle becomes locked securely inside the grapple. The machine lifts the load and slowly turns toward a waiting truck. A worker positioned safely beside the vehicle watches the movement and gives clear hand signals to the operator. The claw travels over the truck bed before opening. The bundle drops with a heavy, flexible impact. The first leaves strike the metal floor and spread outward. Additional layers fall on top and compress the material beneath them. More bundles follow. The guide worker continuously adjusts where each load should be placed, directing some toward the front and others toward the rear so the weight remains balanced. Mud marks build along the inside walls. Large leaf edges temporarily hang over the sides before workers guide them inward. Another truck moves into position as the first one becomes full. Before long, the field road is filled with large transport vehicles carrying enormous quantities of harvested elephant ear leaves. None of the material looks clean. Mud, water, torn edges, and natural residue remain visible across the leaves. The factory has not touched them yet. This is the raw material exactly as it leaves the plantation. The convoy begins moving away from the endless green field. Heavy tires roll through muddy roads before reaching firmer ground. Behind the trucks, the huge plantation gradually becomes smaller. Ahead, the road widens and the agricultural environment slowly begins changing into an industrial one. Eventually, a massive modern facility appears in the distance. The building stands alone across a broad industrial site beneath the same large white clouds seen above the plantation. On the main structure, the name Everleaf Bioleather Works identifies the factory where the leaves will undergo their complete transformation. As the first trucks enter the receiving area, the agricultural stage ends. Every incoming load is registered and inspected before unloading. The condition of the material is checked because the leaves have arrived wet, muddy, and uneven. Some carry damaged edges from harvesting. Others contain heavy stem sections that will later need to be removed. Before any fiber can be extracted, the entire incoming mass must be cleaned. The first truck moves beside a huge industrial washing pool. Mechanical equipment begins releasing the load while a grapple controls the upper layers. Then, a massive bundle drops into the water. The impact sends a powerful wave across the tank. Some leaves disappear below the surface before their natural buoyancy brings them back upward. Others spread almost flat across the water. Mud immediately begins dissolving from the outer surfaces, creating dark clouds around the freshly submerged material. Small pieces of field debris separate and sink. More leaves enter until much of the pool is covered. The first wash is intentionally gentle. If the factory immediately applied maximum pressure to dry dirty leaves, hardened mud and debris could damage the surface or become driven more deeply into the plant structure. So the material is allowed to soak. Water penetrates dried soil around the veins and softens the residue collected during harvesting. Large mechanical paddles move through the pool, slowly separating leaves that have become trapped together. The system does not shred them. It simply keeps them moving so water reaches both sides. After sufficient soaking, the leaves are lifted onto the first washing stage. Dirty water immediately pours from the enormous surfaces. The material advances while wide spray bars release high volumes of clean water from above. Mud breaks loose, runs along the veins, and falls through drainage openings below. This rinse removes the easiest contamination, but the leaves still carry residue. They therefore move into a foam cleaning stage. A controlled layer of cleaning foam spreads across the green surface and fills the deep channels created by the leaf veins. Large, soft brushes lower gradually and begin working across the material. The brushes are flexible enough to follow the irregular shape. When they reach a raised vein, they bend rather than cutting into it. The foam becomes darker as more dirt separates. Water and residue flow continuously toward the edges. Cleaning the upper surface is only half the job. The leaves are turned so the underside faces upward. The lower surface contains thicker structural veins where mud can remain trapped. Narrower brush systems work between. These raised areas, while directed water jets flush out the remaining residue. A stronger rinse follows. High-pressure water strikes the leaves from multiple controlled directions. Foam races toward the edges. Dirty runoff disappears into the treatment system below. After this stage, the original deep green color becomes much clearer. The leaves continue into a final clean water rinse. No foam remains now. Only fresh water moves across the surfaces. By the time the leaves exit this section, the mud from the plantation has disappeared, but the factory still has a large amount of preparation ahead. Every cleaned leaf is inspected. Optical systems scan for damaged areas while workers examine unusual sections manually. Leaves that are too thin or seriously damaged are separated. The best material continues toward cutting and fiber recovery. Large trimming heads remove torn edges. Thick remnants of the stem are separated from the broadleaf sections. The goal is not to create perfect shapes, but to produce consistent material that the fiber machines can handle efficiently. The cleaned leaves are cut into wide strips. Those strips enter another cutting stage where they are divided into smaller sections. The fresh cuts expose the internal wet structure. Long plant fibers become visible among softer tissue. These pieces enter the mechanical opening line. Heavy rollers grip the plant sections and compress them. Pressure squeezes moisture from the material while breaking down softer plant tissue. Instead of crushing everything into a paste, the machine is adjusted to preserve as much useful fiber length as possible. When the flattened material exits, it looks very different from the original leaf. The next machine uses mechanical teeth to open the structure further. Rows of moving elements pull through the plant mass, separating long wet fibers from softer surrounding tissue. The fibers stretch and pull free in tangled groups. At this stage, the recognizable shape of the elephant ear leaf begins to disappear. The separated fibers enter another washing process. Even after the exterior leaves were cleaned, the internal material still contains soluble plant compounds and small fragments of soft tissue. Water circulates through the fiber mass while controlled agitation loosens these remaining materials. The first wash water leaves slightly cloudy. A second cycle produces clearer water. Additional rinsing continues until the fiber reaches the required cleanliness. The clean fiber is extremely wet. It cannot be formed into strong sheets in this condition, so it enters a dewatering system. A large, perforated press closes around the fiber mass. At first, water escapes quickly. As the plates continue moving closer, the flow becomes slower but more concentrated. The fibers compress into dense wet blocks while water drains through thousands of small openings. When the press opens, thick fiber cakes are removed. These blocks are not ready for sheet formation. The fiber distribution is still too uneven. The factory therefore breaks them apart and feeds them into another refining system. Inside the refiner, larger fiber bundles are opened and redistributed. The aim is not simply to make the fibers smaller. The goal is to produce a consistent structure where strong plant fibers can form an interconnected network. Samples are checked repeatedly during this stage. Technicians examine average fiber length, moisture, and uniformity. Material outside the required range is returned for additional refining. Once the fiber becomes consistent, it moves into large mixing vessels. Water is reintroduced in a controlled amount, creating a thick fiber suspension. Natural binding components and stabilizing ingredients are added gradually. These ingredients help the fibers hold together after drying while preserving the flexibility needed for fashion products. The mixture must be carefully balanced. If the fiber concentration is too high, the final sheet can become uneven. If it is too low, the material may lack strength. Too much binder can produce an unnaturally stiff surface, while too little can allow layers to separate. Large mixing arms move through the vessel at controlled speed. The fiber suspension circulates from the center toward the outer walls and back again. Clumps gradually disappear. The mixture passes through a screening system before formation. Oversized fiber knots and unwanted particles are removed. Suitable material continues while rejected sections return to the refiner. Next comes deaeration. During mixing, small air bubbles can become trapped inside the thick biomaterial. If they remain, they could create visible defects or weak spots in the final sheet. The mixture, therefore, passes through a system that removes trapped air before forming begins. Now the material is ready to become a sheet. A precise quantity is deposited across a broad, forming surface. At first, it looks like a thick, wet layer rather than anything resembling leather. Distribution equipment spreads the mixture evenly from one side to the other. Thickness is checked continuously. Where the layer is slightly thin, additional material is introduced. Where it is too thick, excess material is redistributed. The wet layer then enters the first pressing stage. Large plates begin closing around it. Almost immediately, water escapes, the loose mixture becomes thinner and denser. Fibers that were previously floating separately are forced into much closer contact. Under pressure, they begin locking together into a unified structure. The first press opens. For the first time, the material can be lifted as one complete sheet. It is still wet and fragile, but the transformation is unmistakable. A second pressing stage increases density with far greater precision. Sensors check thickness across the width while the machine gradually adjusts pressure. This is important because a handbag panel cannot be thicker on one side and thinner on the other. Additional. Water is removed, the plant fiber network becomes increasingly compact. The sheets now move into controlled drying. This cannot be rushed. If the outer surface dries much faster than the interior, the material could curl or develop tension. If one side loses moisture faster than the other, the sheet may distort. The drying chamber therefore uses balanced airflow and controlled temperature. Warm air moves over both sides while moisture slowly leaves the internal fiber network. The sheets continue through the chamber until most free moisture has disappeared. They emerge warm, firmer, and significantly more stable. But drying alone is not enough. The sheets are transferred into a conditioning zone where they rest under controlled humidity. Internal moisture gradually equalizes. The entire sheet reaches a more uniform state before mechanical finishing begins. Once conditioned, the material enters a softening system. Large rollers flex each sheet repeatedly. The material bends one way and then the other. This repeated movement removes excessive stiffness created during drying while maintaining the strength of the fiber structure. After several passes, the sheets become noticeably more flexible. Another finishing machine corrects surface irregularities. Fine rollers move across the material, smoothing small raised areas without removing the character of the plant-based sheet entirely. The objective is not to make the surface look like cheap plastic. A subtle, natural appearance is deliberately preserved. Next, a strengthening treatment is applied. A measured coating moves across the surface and penetrates the upper layers of the fiber structure. This improves resistance to repeated flexing and gives the material enough stability to hold the shape of a structured handbag. The treated sheets enter a curing chamber where controlled heat sets the strengthening system. Quality testing begins immediately. Afterward, small samples are repeatedly folded. Others are stretched. Some are rubbed against standardized surfaces. Technicians look for cracks, delamination, excessive stiffness, or weak areas. Only stable material moves forward. Now, the factory begins creating the visual character of premium plant-based leather. Large embossing rollers contain a finely detailed grain pattern. Each sheet passes beneath the rotating surface while controlled pressure transfers the texture into the material. The plain sheet changes immediately. Light begins interacting differently with the surface. Small variations in the grain give it depth and a more refined appearance. The factory can create several finishes, but each production batch remains consistent. Material intended for one handbag design uses the same grain, thickness, flexibility. and surface character throughout. After texturing comes color. The sheets enter a controlled finishing area where pigment is applied uniformly across the full width. The first pass establishes the base shade. The material then travels through drying before returning for correction of any uneven areas. Some batches receive deep luxury neutrals. Others receive warmer natural shades. Within each batch, sensors and human inspectors compare colors so that handbag panels cut from different sections will still match when assembled. A protective surface finish is added after coloring. This layer is deliberately thin. It improves resistance to light moisture, rubbing, and ordinary handling while allowing the material underneath to remain flexible. Another curing stage sets the surface. The finished sheets now look dramatically different from the raw plant material entering the factory. They are flexible, textured, evenly colored, and strong enough to be cut and stitched. Before fashion manufacturing begins, every sheet undergoes another inspection under strong white lighting. Technicians look across the material from different angles, searching for pinholes, color differences, uneven grain, scratches, or thickness variation. Rejected. Areas are marked. Approved sheets move into the handbag production department. The environment now changes. From heavy industrial processing to precision, manufacturing large plant-based leather sheets are spread across clean cutting tables. Digital systems analyze each usable area and arrange handbag patterns in positions that reduce unnecessary waste. The main front panel is placed first. The back panel follows. Side gussets are positioned nearby. The base, flap sections, closure reinforcements, handle strips, and strap components are arranged around the larger pieces. When the layout is optimized, precision cutting begins. A guided blade follows the outline of the first panel. It travels smoothly through curves and slows slightly before sharp corners. The finished piece separates cleanly from the surrounding material. Then another panel is cut, and another. Front pieces are stacked together. Rear pieces are grouped separately. Side panels, bases, strap components, and reinforcement sections are sorted according to the handbag model. The cutting department also pays attention to grain direction. Two pieces can have identical dimensions and still look mismatched if the visible surface grain points in different directions. This detail is corrected before the pieces ever reach the sewing department. Structural reinforcement is prepared at the same time. Handbags experience the greatest stress around handles, bases, zippers, and closures. Thin reinforcing layers are therefore cut specifically for these areas. The interior lining begins as a separate material. Large rolls of premium fabric are inspected for flaws and then cut into panels that correspond to the inside dimensions of each handbag. Smaller sections create internal pockets. Longer pieces form zipper compartments. Handles are manufactured rather than simply appearing as finished components. Long strips of plant-based leather are cut to precise width. Reinforcement is positioned inside each strip. The edges are folded inward and aligned carefully. The handle is then stitched along its length. As the seam forms, the flat strip gradually becomes a stronger three-dimensional component. Shaping equipment bends the handle into its intended curve while keeping the attachment ends. Flat shoulder straps undergo a similar process, but their reinforcement is designed for flexibility over a much longer length. Each strap is folded, stitched, edge-finished, and prepared for hardware. Now, the main bag assembly begins. The front panel is aligned with one side gusset. An operator carefully brings the edges together while an industrial sewing machine drives the needle through both layers. The seam begins forming. Each stitch remains evenly spaced. Thread tension is controlled precisely. Too much tension could cut into the plant-based leather. Too little could leave a loose seam. The second side is added. Then the rear panel. The previously flat pieces begin forming a three-dimensional shell. The base panel is positioned underneath and stitched into place. Reinforcement is inserted in areas that need additional support. Once the base is secured, the handbag can partially stand on its own. Inside another workstation, lining panels are being assembled. Interior pockets are stitched. First, a zipper compartment is added, support pieces are attached, behind areas where hardware will eventually be mounted. The completed lining is then placed inside the exterior shell. Workers. Carefully align the top edges before joining the two. Structures. This operation must be precise. A loose lining would bunch inside the bag. A lining that is too tight would pull against the exterior and distort its shape. Once the interior is secured, hardware installation begins. Metal rings are positioned at reinforced points. Handle anchors pass through prepared openings. A pressing tool locks them into position while supporting the surrounding material so the surface is not crushed. Zippers are installed along accurately prepared openings. The slider is tested repeatedly. Closures are fitted. Depending on the handbag design, these may include magnetic systems, mechanical clasps, or other premium fittings. Structured models can also receive small metal feet underneath the base. The handbag then enters edge finishing. Raw, cut edges are inspected and lightly smoothed. A flexible edge coating is applied in a thin layer. It is allowed to set before another layer is added. Gradually, the exposed edge develops a uniform, sealed appearance. This process may seem minor compared with giant harvesting machinery, but poor edge finishing can immediately make an expensive handbag look unfinished. The corners are then shaped. Special forming tools support the handbag from inside, while gentle external pressure helps the material settle into the required geometry. The front becomes smooth. Side gussets open evenly. The base remains flat. The handles rise into their proper position. At this stage, the product finally becomes instantly recognizable. What entered the factory as muddy green vegetation is now a structured fashion handbag, but appearance alone does not mean the product is finished. The bags move into a detailed quality control department. The first inspection looks at symmetry. A finished handbag is positioned inside a measuring frame. Technicians compare the left and right sides, check the height of the handles, and confirm that the base sits evenly. Another station checks handle strength. The handbag is secured while controlled weight is applied gradually to the handles. Technicians observe the stitching and anchor points for movement. Shoulder straps are tested in the same way. Zippers are opened and closed through their entire travel. Clasps are engaged repeatedly. Metal fittings are checked for looseness. The plant-based leather itself is flexed along natural movement points. Side gussets are opened and closed several times. The surface is inspected to ensure repeated bending does not create cracks or whitening. Seams receive close inspection. Technicians examine stitch spacing and thread tension. Any loose fibers or exposed thread ends are corrected. The interior is checked as carefully as the outside. The lining is pulled open and examined. Pockets are tested. Interior zippers are operated. The bottom support is checked to make sure it lies flat. Even the way the empty handbag stands is considered part of the quality standard. It should maintain its designed shape without appearing excessively rigid. Products that fail these tests are separated for correction. Approved bags move into final finishing. Soft cloths remove dust from the surface. The plant-based leather receives a light polish appropriate to its finish. Metal hardware is cleaned separately until fingerprints disappear. The bag is then filled with lightweight shaping material so it maintains its structure during transport. Handles and shoulder straps are positioned carefully. They are not simply folded randomly into the bag. Each completed handbag is placed inside a protective dust bag. The covered product is then lowered into a rigid presentation box. Protective tissue fills the remaining empty spaces so the handbag cannot move excessively during transport. The box closes. Individual boxes are grouped into larger shipping cartons. Every carton is coded according to product model, color, production batch, and destination. The journey now moves from manufacturing into logistics. Finished cartons enter a vast warehouse. Long organized sections hold different handbag collections. Pallets are assigned according to destination. Some are intended for regional distribution. Others will travel much farther. Forklifts collect complete loads and move them toward the dispatch area. Protective wrap is applied around the pallets so cartons remain stable during transport. At the loading docks, large freight vehicles wait outside Everleaf Bioleather Works. One pallet after another is loaded. The warehouse gradually releases the same production that entered the facility much earlier as dirty green leaves. The contrast is extraordinary. At the beginning of this journey, millions of giant plants stood beneath intense sunlight across an endless wet plantation. A monitoring robot scanned the crop. 6 workers ran through the mud toward a selected plant. A heavy blade opened the stem, an inspection probe checked its internal condition, and a massive harvesting machine eventually cut the plant down. Giant leaves crashed into mud. Workers struggled to move them. Chainsaws separated the thickest sections. Harvested leaves accumulated until they formed a green mountain. Heavy grapples compressed and lifted enormous bundles. Trucks carried the dirty material away from the field. Inside this factory, those same leaves were soaked, washed, brushed, rinsed, inspected, trimmed, cut, opened, separated into fibers. Washed again, dewatered, refined, mixed, screened, pressed into sheets, dried, conditioned, softened, strengthened, textured, colored, coated, and tested. The sheets then entered an entirely different manufacturing environment. Patterns were arranged. Panels were cut. Reinforcements were prepared. Lining was assembled. Handles and straps were built. Exterior pieces were stitched into shape. Hardware was installed. Edges were finished. The handbags were formed, inspected, tested, cleaned, protected, boxed, stored, and prepared for distribution. Now, as the final freight vehicles close their doors and begin moving away from Everleaf Bioleather Works, the transformation is complete. What started as an enormous living leaf in a muddy plantation has become a refined, plant-based fashion material and finally a premium handbag ready to enter the market. This journey shows how radically a raw natural material can change when agriculture, large-scale machinery, material engineering, precision manufacturing, craftsmanship, and modern logistics are connected in one continuous system. From endless green fields to polished, finished handbags, this is the complete transformation of giant elephant ear plants into premium, plant-based leather fashion.